And like I said, I'm just going to touch on this today. So the mean value theorem has certain requirements in order to apply. So it doesn't always work, just like our critical point thing. Didn't always work. We were only guaranteed to have a max and min if we had a closed interval and it was continuous. A mean value theorem has a few similar rules. It has to be continuous on a closed interval. So we have a function between 2 points, it's continuous. No breaks in our graph. Okay. If that is true, it also has to be differentiable. What does differentiable mean? It has a derivative. Okay, so things that make it not have a derivative, we already know it's continuous, so there weren't any breaks, but we know corners would make it not have a derivative, so we can't have any sharp corners like that. And the two endpoints are equal, so that's the real big piece. The endpoints are equal. If those conditions are met, then there has to be a number between a and b where the derivative is 0. Okay, if the endpoints are equal, that means it starts and ends at the same point. On the graph I just drew, how many times would the derivative equal 0? Twice. Okay, those places where the derivative are 0, those are like maxes and mins. So it's guaranteeing we have a max or a min there. This is actually Rolle's theorem. It's a special case of the mean value theorem. And I gave you just a few pictures of this. You know, it could be that you just have a constant function in which every point in there has a derivative of 0. We might have a single max, we might have multiple, we might have a single min. Those things are true. I can prove this to you, or do you guys want me to do like an actual mathematical proof, or is my picture justification of good enough? Picture's good? Okay. I mean, I'm happy to prove it, but I feel like sometimes you just tune me out and don't really listen into
it just takes too much to process.
It's a lot. It's a lot to prove. Okay. So let's look at this. If the position of a moving object at 2 different times is equal, what does Rolle's theorem tell us? Okay, so think about if I take a ball and I roll it across my classroom. If the position at 2 different times is equal, so that means, let's say right here, it hits this position multiple times. What had to happen somewhere in that interval? Yeah, we had a max distance, or a point where we had a velocity of 0, because it had to go forward and then come back. So all it's saying is at some point, I think you guys.
All right. Gotcha.
Thank you.
Yep.
So at some point the velocity is 0 or the derivative is equal to 0. All right, what I'm probably going to do is 1, maybe 2, I don't know if I can get 2 examples in, but we'll do an example of this using an actual equation. So suppose that my function is x to the 1/2 minus x to the 3/2 on the closed interval 0 to 1. Find a number c that satisfies the conclusion of Rolle's theorem. All right, so first of all, when we do Rolle's theorem, I'm going to ask you to check the criteria. We have to make sure it works. The criteria is it has to be, look at my slide, 3 things. It has to be continuous, the derivative has to exist, and the endpoints have to be equal. Now a lot of these, I'm going to give you polynomials. If it's polynomial, you can just say it's a polynomial, so it's continuous and differentiable. We've already established that in the past. This one is not a polynomial, but the square root of x, or x to the 1/2 is the square root of x minus the square root of x cubed. Okay, that's going to be continuous. We know a square root graph doesn't stop as long as you're plugging in positive numbers. And we know that it's a nice curve, so it is not going to have any corners, so the derivative exists, as long as x is what kind of number? A positive number. Okay, so I'm not going to be real particular on this. I may give you some that aren't continuous and differentiable, so you have to think about it, but I'm not going to ask you to give me a huge justification for why. Okay, you just have to write down that you've thought about it. Technically, if you want to be really particular, it has to be continuous on the closed interval, so you could say continuous on the closed interval. It only has to be differentiable at the open interval, and this one is actually not differentiable at 0 because that's the starting point. So it's not differentiable, but at the end point, but that's okay. It doesn't have to be. But the big thing we have to check, the endpoints have to be equal. If I put in 0, you get the square root of 0 minus the square root of 0 cubed, which is 0. If we put in a 1, we get the square root of 1 minus the square root of 1 cubed. So 1 minus 1 is 0. So that's the big thing. For Rolle's theorem to work, these endpoints have to be the same. And they are. My Smart Notebook updated and now none of my pins are this ones I had saved. It's kind of annoying this morning. All right. So then the actual theorem says if the criteria are met, then somewhere the derivative is equal to 0. So now we could find that place. So if I do my derivative, x to the 1/2 will be 1/2 x to the negative 1/2 minus x to the 3/2, so 3/2 x to the 1/2 has to equal 0. If we think about what that means, that's 1/2 square root of x minus 3 radical x over 2 equals 0. So we can add that term over, cross multiply, divide by 6, so x is 1/3. Was 1/3 in my interval 0 to 1? Yes. So we found a point in the interval. That works. Any questions there? Last problem of the day. Okay, let's say I have this function. Does it satisfy Rolle's theorem? So my function 1 minus x to the 2/3, that's the cube root of x squared. Cube roots, we can have positives, we can have negatives under there, right? So it is continuous. Basically, for continuous, unless it's a piecewise function, you're just making sure that it exists. It doesn't have any domain issues. Differentiable. Let's check. If we do the derivative, what do we get? What that means, a negative 1/3 is saying the cube root of x on the bottom. Where does this not exist? Right, we know right there x can't be 0 because my derivative would be undefined. So, f prime of x does not exist if x equals 0. Since 0 is in the interval negative 1 to 1, we can't use Rolle's theorem. Okay, my criteria weren't all met. We can find a derivative, but there is an x value where it doesn't exist. Now, if my interval were 1 to 2, could we do Rolle's theorem? Yes, because then 0 wouldn't be in that interval. All right. Any questions? That's where I'm going to stop.